Hi and welcome to leg and hip mobility. We have 8 different exercises to train the mobility of the legs and the hips. And in between these exercises, we're trying to look for an explanation of superluminal motion, and we're trying to understand why this superluminal motion happens and what it is. And participating in the exercises is at your own risk. Let's start with the warm-up exercises, not part of the 8 leg and hip mobility exercises. All 8 leg and hip mobility exercises are with standing on just one leg. Now the warm-up exercise. The legs are standing wide apart and the toes are pointing to the outside. We breathe in and out again. And breathe in and out. In and out. And one more time. In and out. In. We close the legs and we are warmed up to initiate the first of the 8 leg and hip mobility exercises, which are all with standing on one leg. Let's look before at a little intro to the superluminal motion. So what it is first. Superluminal motion is the speed of energy bursts emitted by a black hole called. So there are speed of energy bursts, and they are called that they have superluminal motion. There are energy bursts emitted from the black hole, and they have superluminal motion. And they are called like that because the speed of the energy bursts appears to be faster than light. So there are black holes and they emit energy bursts. There comes energy out, and it appears that this energy is faster than the speed of light. And that is called superluminal motion. Now we are standing on one leg. The other leg is in the air with a flexed foot, and we're swinging the foot to the side and to the side and the front. To the side and the front. So superluminal motion is just called what this energy is doing emitted by a black hole, because it looks as if it would be faster than the speed of light. And now we try to get the explanation why it looks so that these energy bursts emitted by a black hole are faster than the speed of light. And the explanation is with a little example. A star is 6 light hours away from Earth. Now with the other leg. And swing it to the front and to the side with a flexed foot. So in this example, we have a star, and that star is 6 light hours away from Earth. So we are on Earth, and 6 light hours away there is a star. So that's light of its star needs 6 hours to travel to the Earth. So what happens on the star, we on Earth see 6 hours delayed. It is 6 light hours away. And the star travels with 0.6666 light speed towards Earth. Next exercise, again a good standing leg, and the other legs with a flexed foot again in the air. We're bringing the foot in front and back, front and back. So there is a star which is 6 light hours away from Earth, and that star travels towards Earth with a speed of 0.6 times light speed. So it is not as fast as light, but with 0.6, a bit more than half as fast as light. And with the other leg, front and back. There's a star, 6 light hours away, and that star travels with 0.6 times the speed of light towards Earth. So in 1 hour, that star comes 0.6 light hours of distance closer to Earth. The light itself travels with 1 light speed, and that star travels with 0.6 light speed. So around the half of light speed, a bit more. And we have done the second exercise. At midnight we can see the 6 light hours away star from Earth. The next exercise. We are bringing one leg up in the right angle, the foot is flexed, the hips are even aligned. We are tall with the back, and we are bringing the leg to the outside. We breathe in. And we breathe out again, and are putting our leg down. And again we are bringing the leg up to the side. We breathe in and out, and down with the leg, and now with the other one. The leg comes up, even aligned hips, right angle with the leg, flexed foot, tall with the back, and we're opening the leg to the side. We breathe in and we breathe out, and are putting the leg down. And one last time. Up with the leg, right angle, flexed foot, even aligned hips, tall, back, to the outside. We breathe in and out back into the middle and contract down. So at midnight at 0 o'clock, we can see a star 6 light hours away, so pretty far away. The light of a star needs 6 hours to travel to Earth, and that star travels towards Earth with a speed of 0.6 light speed. So the light of a star comes with that speed, and the star around with a half speed of the light. Now, at 0 o'clock, the star is 6 light hours away. The light of a star will reach Earth 6 hours delayed at 6 o'clock in the morning. So at midnight, the star is 6 hours away, and the light will come 6 hours delayed on Earth. At midnight, the light is here, and 6 hours later, the light comes to Earth. And now it's 6 o'clock in the morning on Earth, and we see that light. Next exercise, same setup as we had with the last one. The leg comes up, right angle, flex foot, straight and tall the way. And now we are pressing with the hand against the inside of a knee. So at 0 o'clock, yes, at 0 o'clock, the star is 6 light hours away, and we on Earth will see that star 6 hours delayed at 6 o'clock. Now with the other leg, bring the leg up, tall, even lined hips, flex foot, and we're pressing against the inside. We will see that star at 6 o'clock, the light of that star at 6 o'clock, 6 hours delayed. And with most the other leg. Now at 1 o'clock, so 1 hour later, the star is 5.3 light years away. So that star was 6 light hours away. And at 1 o'clock, 1 hour has passed, and that star has traveled for 1 hour closer to Earth. And it was 6 light hours away, now it are 5.3. It travels with 0.66, so 0.7, and now it's no longer 6 light hours away, but at 1 o'clock, 5.3. Not 6, but 5.3 light hours away. Same setup as we had with the last exercise. Right angle with the leg, flexed foot, tall with the back, even lined hips, and we're pressing with the knee up into the hand and to the side. The knee presses up into the side. So at 0 o'clock, the star was 6 light hours away, and the light will reach us at 6 o'clock in the morning, 6 hours later. And now with the other leg, again the leg up, even lined hips, right angle with the foot, right angle with the leg, flexed foot, tall with the back, and the knee presses up and to the side. At 0 o'clock, the star is 6 light hours away, and the light will reach us at 6 in the morning. At 1 o'clock, the star has come 0.7 light hours closer. It has traveled towards us, and the light will reach us in 5.3 hours. So the star is closer to Earth now at 1 o'clock, and the light of that star at 1 o'clock will reach us not in 6 hours, but just in 5.3 hours. It's 0.7 light hours closer. It has traveled 0.7 light hours closer to Earth. 5.3 hours later than 1 o'clock. At 1 o'clock, the star is 5.3 light hours away. So 5.3 hours later, that light will reach Earth. And that would be at 6:20. 5.3 hours are 5 hours and 20 minutes. 0.3 hours and 20 minutes. Now the next exercise. We are placing one hand on the tummy and one on the back, and we are lifting our leg up. The leg is straight, the foot is flexed. If that muscle cramps, bring it up and point the foot. So we're trying to bring our leg up, and we're trying to bring it higher. We're controlling with our hands that we have an position with the spine. So now at 1 o'clock, the star is 5.3 light hours away. And for the light to travel these 5.3 light hours, it will need 5.3 hours. So that, and we bring the leg up, so that the position of the star, now at 1 o'clock, will reach us 5.3 hours later, when 1 o'clock. So 1 o'clock plus 5. The other leg comes up, one hand on the tummy, one on the back, and straight leg and flexed foot, and we're trying to bring it higher. So the light of a star at 1 o'clock will reach 5.3 hours later at 6:20. The star is closer, and the light will reach us already in 5.3 hours. At 0 o'clock, it was 6 hours, and now at 1 o'clock, it are 5.3 hours. We're bringing the leg up and pointing the foot. So that light at 1 o'clock will reach Earth at 6:20. And now something has happened here. On Earth, we see the star 6 light hours away at 6 o'clock and just 20 minutes later at 5.3 light hours away. Next. That means it appears that in just 20 minutes from 6 o'clock to 6:20, the light has traveled 0.6 light years. And that would be twice the time of light speed. So, the leg points to the outside, the other leg is by the heel on the ground, and we're lifting the leg up and putting it again on the ground. So on Earth, only 20 minutes have passed, from 6 to 6:20. And at 6 o'clock, we had seen the star 6 light years away, and at 6:20, we see the star 5.3 light years away. And on Earth, just 20 minutes have happened, and the star is 0.7 light hours later to Earth. And we switch the leg. And that means in just 20 minutes, that star had traveled 0.7 light hours. And in 20 minutes, 0.7 light hours would be 2.1 the times of light speed. 0.3 in 20 minutes. 20 minutes are 0.3. 20 minutes of an hour is a third of an hour. And so it makes in just a third of an hour 0.7 light hours. So 3 times in an hour it would make 2.1 light hours. So it appears on Earth that star has made 2.1 light hours in 1 hour, or other way around, and 20 minutes 0.7 light minutes. Now, the last exercise, we have a standing leg, the other leg's with flex foot in the air, and we bring the leg back and up, and the upper part of the body goes down in one straight line. So that star is at 0 o'clock, 6 light hours away, and the light of a star will reach Earth at 6 o'clock in the morning. At 1 o'clock in the morning, the star has come 0.7 light hours closer to Earth. In 1 hour, 0.7 light hours closer, so it's not light speed, it's less than light speed. In 1 hour, at 1 o'clock, the star has come 0.7 light hours closer over the other leg. But that light will reach us in just 5.3 hours, because it was 6 in the beginning and now it's 0.7 closer. So in just 5 hours, 30 minutes, it will reach Earth. And 1 o'clock plus 5 hours, 30 minutes is 6 o'clock and 20 minutes. And 6 o'clock and 20 minutes is just 20 minutes later, when we had seen the star at 6 o'clock, 6 light hours away. And we think, no, we're done with exercise, it's just a closing exercise. We breathe in, it's an opening exercise. So at 6:20 we think that star has made 0.7 light hours in just 20 minutes. And 20 minutes is a third of an hour, so we have to multiply this 0.7 with 3 and have 2.1 and cosmetics. And that means that star appears to have traveled with 2.1 times of light speed. Okay. So, superluminous motion is what's been called. Here's the Earth at 0 o'clock, and there is a star 6 light hours away. We will see that light of its star at 6 in the morning. The star travels with 0.7 light hours towards Earth. So at 1 o'clock, 1 hour has passed, the star has traveled 0.7 light hours closer to Earth and is now 6 minus 0.7 light hours away, so 5.3 light hours away. The light of a star at 1 o'clock will need 5.3 hours to reach Earth. And 1 o'clock plus 5.3 hours is 6:20 in the morning. So at 6 o'clock in the morning we had seen the star 6 light hours away, and at 6:20 we see that star 5.3 light hours away, and in just 20 minutes on Earth that star seems to have traveled 0.7 light hours, and that would be twice the speed of light. And this has been called superluminous motion because it appears to be faster than the speed of light. I thank you very much, and until next time.